Okay. Doing pretty well with this, but there's still details. And to make sure you've got the details, well, there are a bunch of rules that you've got to follow. And there are a couple of ways to do this. So I'm going to do it in the way everybody's working it, okay? And then I'm going to do it with fractional exponents using x to the 1/2 instead of x, the square root of x. Okay, so you got ax plus d square root of x. Now let's just put some numbers in there. Let's say it's 6x plus 11 square root of x over 10x minus 15 square root of x. Okay. To rationalize the denominator, we multiply this by 10x plus 15 square root of x over 10x plus 15 square root of x. Now that's the rule, okay? You just, this minus this, you multiply by this plus this. And if there's a plus here, you'd use a minus over here. But if you do the distributive law and all the details, you see that's always going to work. That's actually related to the special formula that a squared minus b squared equals a minus b times a plus b. And that's like an a minus b times an a plus b, right? That's going to give you this squared minus this squared. Now, you don't want to shortcut that. You want to use a distributive law so you understand why, because then it's going to be more accessible to you when you take a test. You might remember the trick, but it's more than a trick. It's an application of the distributive law. And we want to really be straight on the distributive law. As I've said repeatedly, you don't want to stumble over the distributive law when you get into precalculus. You don't have time to be stumbling. There are other things you got to pay attention to. Okay, so we do this multiplication. So first of all, we get 6x plus 11 square root of x multiplied by 10x plus 15 square root of x divided by 10x minus 15 square root of x times 10x plus 15 square root of x. Again, we multiply the numerators, we multiply the denominators. Well, the numerator here, then I'm going to do all the steps of the distributive law. And let me emphasize that the distributive law a lot of times can be written like this. If I get the error. Okay. You can do that, but that doesn't inform you about every possible application of the distributive law. And I keep emphasizing that I really want you to not shortcut it. I want you to write it out. After you've done that a dozen times or more, then it kind of locks in what's going on and you can apply it in different situations. So I totally recommend that you do the steps. That's not be a shortcut to the steps, and so some of you with the shortcuts got it right. So that's good, but make sure you understand what you really do, okay? So we write this as 6x times 10x plus 15 square root of x plus 11 square root of x times 10x plus 15 square root of x. All that over the denominator. Again, what I did in the numerator, it's 6x times x plus square root of 11 square root of x times all this. And it's 10x times all this minus 15 square root of x times all this. If you've done some of these, you know how this is going to work out. But make sure, because not everybody is seeing all of it. You really want to be sure that you see the distributive. Okay. And reinforce to yourself what the distributive law says. Okay, well, there's an intermediate step in the distributive law. Notice we haven't done this, but it comes down to the same thing in this case. Okay, so that's going to be 6x times 10x. This times this, plus this times this, plus 6x times 15 square root of x. And then here it's 11 square root of x times your 10x plus 11 square root of x times 15 square root of x. Divide that by 10x times 10x plus 10x times 15 square root of x. And see, I wrote this down, did something. I pretended to make a mistake when I wrote this down because some of you are pretending to make the same mistake. Okay, I didn't write the x on this. It's very easy to do that. Very easy to leave the x in the square root of x because you're looking at the numbers. Be careful. Keep your maintain good bookkeeping. 10x times 10x plus 10x times 15 square root of x, and then minus 15 square root of x times 10x, and minus 15 square root of x times 15 square root of x. Now we've got everything expanded. We want to simplify these terms. So 6x times 10x is 60. X times x is x squared. So we get 60x squared here. Now you can, the hang up is that x times x, right? You could rearrange. Let's just do that real quickly. 6x times 10x is 6 times x times 10 times x. Now, actually, I'm being a little loose with the associative and commutative rules here, but this is 6 times 10 times x times x. There's a multiplication because of the associative and commutative laws. We can write the numbers in any order. And that 6 times 10 is 60, and x times x is x squared. So we can just write this out as a product of 4 things, switch the order, and see that this is what we get, okay? You really want to understand that because otherwise you get confused. It's like there's one rule, which is that you can do this, but you tend to see it as 15 different rules because it looks different in different situations. One rule. Okay, now I've noticed that the camera has chosen to, oh man. Camera's chosen to mess up, and then I messed up on top of that. Okay, that's pretty good. Now let's see if we can, yeah, okay, it's fine. Okay, I don't know why. I don't know what happened. And there's no way to fix the thing. You can't have a fixed focus with this camera. It's got to have its own way. Okay. Okay, anyhow. Then 6x times 15 square root of x. Well, that's 6 times x times 15 times the square root of x. So you're going to have 6 times 15, which is 90. And then you're going to have x times the square root of x. There's no shorter way to write that unless you use a fractional exponent. And when we get everything done, we will see how that works out with a fractional exponent, okay? Anyhow, then we have 11 times 10 square root of x times x. And you want to be careful that you don't extend that square root over this x, just, by being a little careless the way you write it. You see that okay? It's 110, and let me write it there. That is a little small, maybe a little bunched up. 11 times 10 is 110. Square root of x times x. And I want to write a dot or a parenthesis here to make sure that I don't accidentally see this x as being under the square root. Okay? Because it's not. And then it's Well, 11 times 15 is 165. And it's the square root of x times the square root of x. In the denominator, I'm not going to explain every step at this point, but 10 times 10 is 100, and x times x is x squared. Then 10 times 15 is 150, and that's x times the square root of x. And this is minus 150, square root of x times x. And at this point, you see that these two terms are the same because it doesn't matter which order you write the x and the square root of x, it's the same term. And then it's plus 165 times, again, 15 times 15, it's minus 165 square root of x times the square root of x. And it's not 165, 15 times 15 is 225, and everybody knows that. Not me, apparently. Okay, let me write it out correctly. 15 times 15, 225, and square root of x times square root of x. Okay, next, we're going to be able to combine this term and this term because x squared of x is the same as square root of x times x. Got a question? Okay, so just had a question about reading this thing. Not everybody saw the dot that I had there, so I made it bigger. I think we'll put it on this. Okay. So this is 60x squared plus I'm just trying to see if I've got room to. Yeah, I can probably do it. Okay, I'm going to do an extra step here. If I write in the order x square root of x, I don't need any dots. It's clear what's separated and what isn't, right? So we just have the 90x square root of x here. And I wrote the square root of x times x here as x times the square root of x. So that we can, as clearly as possible, see that this term and this term both have an x square root of x in. Then 165x, because the square root of x times the square root of x equals x. Now, one way to see that, I'm going to digress here a little bit from the process, because we want to be sure we see why the square root of x times the square root of x is x. First place, the square root of x is the number you multiply by itself to get x. And I just multiplied it by itself and I got x, okay? That's what a square root is. The example is, what's the square root of 25 times the square root of 25? So let's write that out, square root of 25. Now this is written really small, just so I have room. It just says square root of 25 times the square root of 25 is 5 times 5, and that's 25. Okay? So it makes perfect sense that that should be the case. There's a little caveat on that. It's actually the absolute value of x, but since, well, you don't do square root of a negative anyhow, and we're going to address that with quadratic formulas in a little while, okay? And we'll see how complex numbers work. Very similar. What you do to divide complex numbers is very similar to what you do, because what you're doing here is you're really dividing this by this, right? And what you're getting is a different expression for this divided by this that doesn't have any square roots in the denominator. There's another question coming up here. Okay, couple of questions. I already forgot what the first one was, but the second one, maybe the first one will come back to me, or I'll ask you to repeat it. You can't just divide this by this and this by this and this by this, okay? In the simplest possible example, Okay. This isn't equal to this because this is equal to 8 over 3. Well, you're not getting the common denominator of 3 over here, or anything that even contains 3 as a factor. You're going to get a common denominator of 28, and you can't even get a 3 out of 28. Even if it reduces, you're not going to get a 3 down there because 3 doesn't divide 28. Okay? So this is not equal to 5/7 plus 3/4. Okay? Now that's equal to what? That's equal to 48 over 28. Okay, which reduces down to 24 over 14, which reduces down to 12 over 7. Okay? So I think that's 12/7, and it's nothing like this. Okay? So you want to be careful about that. Now, this is equal to 5 over 7 minus 4 plus 3 over 7 minus 4. Because dividing by 7 minus 4 is multiplying by the reciprocal. Okay, 1 over 7 minus 4 times 5 plus 3 by the distributive law is 1 over 7 minus 4 times 5 plus 1 over 7 minus 4 times 3. That would be valid. So over here, it would be valid to say that this is 6x divided by all of this plus 11x divided by all of this. But it's not 6x divided by this plus 11 squared of x divided by 15 squared of x, or negative 15 squared of x, okay? That doesn't work. It's not justified by the distributive law. And what I'm doing here is as much about the distributive law as it is about how you divide two rational expressions, okay? Make sense? So you really want to try to make sense of that because it will help you avoid confusion in some very confusing situations, okay? Okay, well, let's move on to the rest of this. We've got the numerator and the denominator can be written similarly. I might as well. Plus, looking in the wrong place, I'm using my eyes instead of my brain, so don't do what I do. You get in a hurry. And you do math by what it looks like, and you look at the wrong thing. And you're dead in the water at that point. Okay, this x square root of x times square root of x is x. There we have it. Okay. So now we've rearranged this where we see that we've got a couple of like terms here. And we can combine them. We're going to do that using the distributive law. I'm not going to have room, but I'll throw another board up here and we'll get it. One other side comment before we do this is also square root of x is x to the 1/2.
There's where the 1/2 stays.
Okay, because the square root of x times the square root of x has to equal x, right?
Yeah.
Now, if you write it as x to the 1/2 times x to the 1/2, your rules of exponents tell you that this is x to the 1/2 plus 1/2, which is x to the 1. So if you prefer to write your square roots of x as x to the 1/2, so I have no problem with that. Okay? Some people are a little more pedantic than I am, and they might be right, but I might be right. Okay? And I'm going to give you the freedom to do that. Okay, most people I think will. Depends, people have different philosophy of how to teach mathematics. And I'm kind of a stickler for rules, but not that much of a stickler. Okay, but somebody who is, I can't say that there's anything wrong with that. So you get different math instructors. You're going to get different philosophies about detail. And some people tell you to do this. I don't think it's a good idea, but they seem to get okay results. Their students will make mistakes that mine won't, and my students will make mistakes that theirs won't. Okay, well, all that aside, to separate all this, here's a fraction, okay? Now I'm going to do another step. It should eventually be unnecessary, but right now I kind of think we want to do this. Okay. This and this. The reason you can add the 90 and the 110 is because of the distributive law. This is +90 110 times x square root of x. Because obviously, if you multiply this out using the distributive law, you're going to have 90 times x square root of x. And you're going to have 110 times x square root of x. And then this is plus, we've already said that's x. I'm looking up here. Apparently my eyes have a mind of their own, which overrules whatever mind I have. So, okay, let's put a box around this. We don't confuse. So I don't confuse it. Okay. Now down here, then we can write 100 x squared plus 150 minus 150 x square root of x minus 225x. Now, if I wanted to get really detailed about this, I'd start with set theory and prove that 150 minus 150 is 0. Okay, but we know that. So, they're deeper mathematical rules that you're not going to have to worry about. Okay, you can certainly accept that 150 minus 150 is 0, common experience. Okay, so we've got 60x squared plus 90 plus 110x. I'm just rewriting what I've got there. X square root of x plus 165x. All that divided by 100x squared plus 150 minus 150 x square root of x minus 225x. Written kind of small. It's the same things we got here, but just so we don't lose the thread. Then 90 plus 110, 200, that's an easy addition. I didn't put my square on this x. Be careful, like I'm not. And then this is going to be plus 0 minus 225x. Well, plus 0, we don't have to write it. I'll smudge it out to show you that it was there, but it's not there anymore. Okay. Now we don't have any square roots in the denominator. There is another step that we could take and probably ought to. Now we could factor an x out of these two terms. So that could be 60x squared plus 200x square root of x plus 165x. All that divided by x times 100x minus 225. Why does that work? It's again because of the distributive law. Because if you multiply this out, you get x times 100 and x squared. And x times negative 225 is negative 225x. So, factoring out a monomial is just another example of a distributive law that doesn't look anything like this. And it may be a little bit like this. That one looks like something times this is this times this plus this times this. Okay, you want to use that picture to visualize it, okay, but be sure you can write it out. And again, I really advocate writing things out so they look like this until you're really comfortable with the whole process. And when you get into pre-calculus and you've forgotten some details, write a couple of them out like this. Then you'll be reminded, you'll understand what the rules are, you'll understand how everything comes about, okay? And you're going to be much less likely to get confused by some other weird expression. Now, one more thing here. And that is that, I'll write it over here. You write x square root of x with fractional exponents. Well, x square root of x is x to the 1 times x to the 1/2, right? We accept that? Can you see it all right? So you have a little trouble seeing it. X squared of x is x to the 1 times x to the 1/2. This is important. I just think a little bit. I'm kind of writing for the camera, and I forget that I've got people here, but almost all of this that I do with people. So I don't know. I've got to train myself. Okay. Okay, we got x. Square root of x is x to the 1 times x to the 1/2. And of course, this is x to the 1/2 because of what we wrote over here. And let's make sure. Yep, I can't see that on the screen, so I'm going to have to cover a little bit of my work here. Probably deserves it. Okay, that's x to the 1 times x to the 1/2. And that 1 looks like a prime. Something you probably wouldn't confuse at this point, but let's write it work out. Okay, and that's x to the 1 plus 1/2. And 1 plus 1/2 is, well, 2 halves plus 1/2 is 3 halves, right? Complete detail. It's x to the 3 halves. Okay, and there's a distributive law involved in this addition too, but I'm not going to push my way. Might lose your attention. Okay, let's just make sure we understand this. Okay, so there's a bunch of algebra in here, and not just the distributive law, but fractional exponents, or what the square root means, or what x square root of x means. Several applications of the distributive law, which is the main thing I'm trying to emphasize, but other stuff that we've kind of illustrated. Okay, so take that as an example, and I'm going to let this stand alone as a